Most users believe browser wallets are impenetrable vaults. They generate a seed phrase, lock it, and assume total security. But that safety is an illusion. The underlying vulnerability lies in how those keys are created. Standard wallets rely on cryptographically secure pseudo-random number generators to mint your private keys. While mathematically complex, these generators are ultimately deterministic algorithms. They require a starting point, usually system data like mouse movements or clock ticks, to produce an output. If a hacker can perfectly replicate that initial system state, they can theoretically predict the exact resulting key. Beyond key generation, standard web wallets expose users at the network layer. They typically force the browser to communicate directly with public blockchain nodes. This direct routing broadcasts the user's IP address to public servers. Furthermore, it triggers strict cross-origin resource sharing, or CORS, blocks and rate limits from public endpoints, leading to failed transactions. A financial tool built on predictable mathematical seeds and exposed network layers cannot provide true institutional-grade security. The DApp Players Collective Sovereign Hub version 2 is a progressive web application engineered specifically to bypass these browser-based limitations. This new architecture rests on two structural pillars, replacing algorithmic pseudo-randomness with true quantum entropy, and routing all network traffic through a zero-knowledge edge proxy. The system operates under a strict zero-knowledge mandate. All cryptographic operations occur entirely on the client side, meaning no server ever intercepts or stores private key material. To understand how this works in practice, we need to trace the exact lifecycle of a DPC wallet, tracking the data flow from the moment of quantum key generation through to the execution of a network transaction. By combining quantum physics with edge computing, DPC turns an everyday mobile browser into a highly secure, self-contained financial environment. Key generation begins at the edge. A Dino Edge function fires a network request directly to the Australian National University's Quantum Random Number Generator. The function retrieves a highly specific payload, an array of 32 bytes or 256 bits of quantum random unsigned 8-bit integers. Upon receiving this data, the Edge function validates its structure and completeness. If the university server happens to be unreachable, the system gracefully drops back to a local pseudo-random generator, distinctly marking the wallet's provenance in the user interface. Assuming a successful fetch, this raw data represents true physical randomness. It is extracted directly from quantum vacuum fluctuations, completely independent of algorithmic generation. Injecting actual quantum mechanics at the very first step of key generation guarantees the resulting wallet is mathematically unpredictable. The 256-bit block passes through a BIP39 algorithm, outputting a 24-word recovery phrase. This phrase is fed into a PBKDF2 key derivation function, expanding into a 512-bit seed. The architecture then partitions exactly the first 32 bytes to become the final Solana key pair. At this exact moment, a strict security boundary is enforced. The Edge function delivers the public key and mnemonic to the client interface, then instantly purges all memory of the operation. This absolute compartmentalization ensures that the raw key material only exists within the volatile local memory of the active browser session. Generating a secure key in memory is one thing. Storing it persistently in a browser requires a robust encryption pipeline. To lock the wallet down, a custom PIN is combined with a 16-byte random salt. This combination passes through 100,000 PBKDF2 hashing iterations. This computational weight yields a secure 256-bit AES key, locking a private key and 12-byte IV into a sealed ciphertext block. The private key is then encrypted using AES 256 GCM. The Galois counter mode is critical here, as it provides built-in tamper detection to guarantee the integrity of the ciphertext. Version 2.0 introduces a multi-wallet registry to manage multiple accounts. Each wallet is assigned a unique hex ID, ensuring that its encrypted payload and its specific cryptographic salt are stored in completely isolated registry keys. Even in the event of total device compromise, a malicious actor only extracts scattered, heavily encrypted blocks of data that remain walled off from each other. With the private key safely encrypted at rest, the wallet must eventually communicate with the Solana mainnet to execute transactions. Pointing a browser directly at a public node fails instantly due to cross-origin resource sharing blocks. The Sovereign Hub solves this by rerouting all traffic through a Deno Edge proxy. This proxy injects a dedicated API key and successfully forwards the request to the mainnet. Crucially, this proxy returns the correct access control headers back to the user, satisfying the browser's CORS requirements immediately. The Premium Alchemy API key is read strictly from server-side environment variables. It never touches the client's front-end code, protecting the endpoint from scraping. To prevent abuse, the Edge proxy enforces a strict method allow list. It permits exactly 8 specific RPC commands, such as requesting a balance or sending a raw transaction, blocking all other external traffic. This proxy infrastructure builds an invisible tunnel between the browser and the blockchain, bypassing persistent web limitations without exposing network vulnerabilities. The resulting architecture operates across 3 distinct tiers: front-end web cryptography, stateless edge functions, and external providers, all functioning in precise synchronization. All of this complex infrastructure is packaged inside an installable progressive web app. It features an ethereal design aesthetic optimized specifically for mobile viewports. Beneath the interface, the absolute rule holds firm: no servers store cryptographic secrets. Users maintain direct, unilateral control over their public keys and balances, completely removing centralized exchanges from the equation. By layering quantum entropy beneath advanced local encryption and zero-knowledge edge routing, the DPC Sovereign Hub delivers institutional-grade financial security directly into a seamless web experience.